Yeah, good morning, good afternoon, good evening. Today I'll talk about CoreBigBench, which is a benchmarking big data core operations benchmark. And we developed in cooperation with multiple people, as you can see. I will not say all the names, so brief outline. So first I'll motivate and give you a background on benchmarking and how we came up and why we came up with this benchmark. Then I'll give you an overview of the CoreBigBench specification and the elements of this benchmark. And finally, we'll finish with a short conclusion. So let's start. So we live in a world where we have many emerging new big data systems going into all kinds of different directions. And to develop and to improve all of these systems, we see emerging big number of big data benchmarks. And I think we saw today already quite a good overview of the need and why we need to benchmark. And typically we have two classes of benchmarks, micro benchmarks, which focus on testing specific functionality or single operations. And these benchmarks, the micro benchmarks, they are developed to focus on a particular engine. So probably all of you know word count and Pi and TerraSort, which were developed initially to stress test Hadoop and MapReduce. Then we had multiple Hive benchmarks, which were again developed specifically for Hive. And then Spark benchmarks like SparkBench. So basically we have for all these different engines, particular micro benchmark. Then the next class of benchmarks are the end-to-end application benchmarks, which focus more on a business problem, which is usually a real-world application. And examples there, we'll look at BigBench and the BigBench V2. And I'll give you here a short overview of both. So I guess most of you are familiar with BigBench, which was later standardized as TPCx-BB. And it was the first end-to-end big data benchmark. It was relying on TPCDS, so it was using the schema of TPCDS and also some of its queries. And additionally, in BigBench were introduced semi-structured and unstructured data. And the focus of BigBench was towards this new parallel database management systems like MapReduce and Hadoop. It consists of 30 queries, so that's important. And the implementation was done in HiveQuell, Spark, and SparkMLlib. And there are also other implementations. So later in 2017, we proposed BigBench V2, which basically addresses the shortcomings of BigBench, which was in general quite a big rework of the existing BigBench, where we suggested removing all the TPCDS components, starting from the schema and the queries also. So and then we reintroduced a new concept of late binding, which was based on the new implementation of the semi-structured data in the form of clicks, so in the form of JSON log files. And then in addition to that, we simplified the entire data model to include less tables. And of course, we needed for this a new data generator, which was developed again, generating based on scale factor. And the queries that we removed from TPCDS, we replaced them with new queries which were focusing on this new web logs data or the semi-structured data. So, and yeah, so these are basically the differences between the BigBench versions, and this is how an application benchmark looks like. And now we come to the question, okay, what is not covered by micro and application benchmarks? And we see here missing gaps. So both the micro benchmark and the application benchmarks are usually tuned. And so the micro benchmarks focus on the stress testing particular engine features, whereas the application benchmark focus on a realistic use case and use very specific operations. And therefore, there is a need for a big data white box benchmarking, which means that we need to test the core engine operations. And with core engine operations, we mean operations like table scans, two-way joins, aggregation, and window functions. Also, common user-defined functions like sessionize, path, and others. And we think that these core operations can really help with performance regression testing of big data systems. And in addition to that, in such benchmark will not replace either the micro benchmark or the application level benchmark. It should be seen as a complementary benchmark. And furthermore, actually we have a proposal from 2010 done by Alan and Ahmad, where they presented a benchmark which was again on core operation, but for database management system. And actually our idea is very similar, but the focus here is on the new big data systems. And now I'll go through the main components of the new benchmark. And we'll start with the data model. And for the data model, we are inspired by the BigBench V2, which I already mentioned. And as I mentioned there, we simplified the schema. So we have 6 tables which represent the structured data. You can see here. And then in addition to that, we have the semi-structured part, or the JSON files, which are in the form of web logs. And here you can see an example. So they can be divided in 2 parts. The first part are the user clicks information, which will be the user ID, the time, the name of the web page, the product name. And then in addition to that, we have random keys generated here, these keys to simulate the big data payload. And additionally, we preserve the unstructured part, so which was the product reviews, which were exactly the same as the original BigBench. And yeah, as I mentioned, we use this new data generator to generate the data. So this is the base data model and the data that we take for CoreBigBench. And furthermore, we define 22 workload queries, which operate on these different data types. And we divided here the queries in multiple categories, as you can see. So we have scans, which are doing different, which are varying, and depending on the selectivity of the data. And what we did, we have scans which work on the structured and scans that are executed on the semi-structured data. In a similar way for the aggregation function, so we have also variations there. We have a number of Windows functions which also use different data partitioning, joins on both structured and unstructured data, and the common big data functions. Currently we have defined 4. So these are like 4 which are also initially in BigBench. So sessionize, path, sentiment analysis, and k-means. And they were again on the 3 different data types. So what's important also to mention here is that these queries, they have different complexity. And for example, some of the scans are quite simple, whereas others are complex. And what we do is we use them as a kind of Lego concept, and we subtract the operation time from the simple one, from the more complex, and in this way we try to find the delta and to reach this the functionality that's not measured. The other important thing is that we try to avoid the data transfer between the data engine and the client, so this overhead. Here I have 2 slides where there is the complete list of queries. So here the first 11, and then we have another 11. And actually this is the textual description of the queries. And the idea is, we have it in the paper, and the idea is that everyone can take it and implement it for their engine. And in this way, you are basically implementation independent. And now let's look at the proof of concept. So what we did in order to implement them. So here the idea was to show the feasibility of CoreBigBench, and we did not do any serious tuning and testing. We used 4-node cluster with Cloudera distribution and Hive. And we generated data with scale factor 10. So you can see also here in the table the exact sizes. And here you can see how the web logs were stored. So they were stored in HDFS, and we applied the late binding, which means that we directly access the data on the fly. So this means the work files were parsed on the fly when executing the query. Yeah, so they were defined here as external table, and the file was stored, this JSON file, in HDFS. And we'll see later how this was used in the queries. The code, so we did the Hive implementation, and all the query code is available also in GitHub. And now I'll look at some of the queries just to give you an idea how they look like. We structured them in 3 ways. So here, these are queries that are operating on the structured data. So query 2 is just a simple scan operation with wall selectivity, 10%. And as you can see, the code is quite straightforward. On the chart below, we give you an idea of the execution time. So you can see that all the queries have different execution times. And here you have to keep in mind the thing that I mentioned in the previous slide, that we also did subtraction from the core full table scans. And another important thing to mention is that we defined the geometric mean as a benchmark metric. And so this is the one of this group of queries. So the next group are the queries executing on the semi-structured data or the weblog files. And you can see as example query 4 here, which is quite simple. It is just, so what it's doing is extracting this web page name from each line of the log file. And for doing this, we use this JSON tuple user-defined function, which is part of Hive. Yeah, and here on the right, again, you can see all the queries which are in this group, which are working on the semi-structured data. And again, we did some subtraction of this basic operation and report the geometric mean here for this group of queries. And the third group actually are the user-defined functions. So we put them in one group since they're quite different. And here, this is query 22, which is a query from BigBench, from the original BigBench. This is just the part of it, which is actually using the k-means user-defined function. And you can see here on top the typical 2 parameters that you give. So the cluster, the cluster centers and clustering iterations. And what's different here is that we use Facebook library for this implementation, whereas the original BigBench uses Spark MLlib. And here again, you can see the 4 queries and their times. And again, depending on if they were executing on semi-structured data or structured, we were deducting different basic operations. And then the geometric mean. And yeah, so to conclude, in this paper, we presented CoreBigBench, which is a benchmark assessing the performance of core operations like scans, two-way joins, user-defined function. So the benchmark consists of 22 queries applied on structured data, semi-structured key value weblogs, and structured product reviews. And as we mentioned, so they are taken from BigBench v2. What's important is that the queries are textually defined, and we also provide implementation in Hive. And for what can be CoreBigBench used? So it is a complementary benchmark to an end-to-end benchmark like BigBench. It can be used in addition to this. And yeah, it can be used for regression testing of commercial and open source big data engines. And it can be easily extended. So one possible extension will be to include ETL operations, which are very useful nowadays and are basically part of almost all engines. And I think these are the slides. So thank you for your attention. And if you have questions, so I have here also the references.
Thanks, Theodor.
I hope I'm in time, so.
Yeah, you are on time. So we do have some time for questions. Anyone?
I think also even Ahmad is also here, so.
Yeah, we have multiple people who can answer. Okay, I am not seeing any raised hands. So yeah, maybe to kick off, I mean, for you, I also know that, I mean, you have worked with analyzing Spark Hive using BigBench. And I mean, I guess, like, was it like some of the frustration you had during that process that made you want to do this, like have a more micro benchmark solution, or?
Yes, yeah, it was. Yeah, I think yeah, it was one of the motivation. As I said, so one thing was that we have these micro benchmarks, but then the problem is that once you start implementing, you cannot really compare them one-to-one because they always focus on the implementation. So you already have always given the implementation. And then it's not the case that this other engine that you want to compare supports exactly this. Mm-hmm. So you need a bit more high level. And yeah, I think this was one of the main drivers. And also in terms of regression testing, as I mentioned, I think it's can be quite useful, especially, I mean, we saw also the first keynote, I think they also motivated quite well there why we need this. So I think this is exactly complementary to this.
And so potentially though, while re-implementing these for the different systems, like, can there be some discrepancies, like in terms of having apple to apples comparisons, if I really want to compare two systems based on this kind of benchmark?
Yes, but yeah, it can be. So it's not that straightforward. Yeah, that's sure. But the thing is, how otherwise, how do you define this core operation? Mm-hmm. So these operations that we see more and more are offered by many engines. Mm-hmm. So.
Yeah.